Okay, so in this video, I'm going to talk about how to solve for the sides of a right triangle using trigonometry. All of this starts off with being able to identify the sides based on the angle that you're given. And so we'll start off with that. The first thing to always look at is that the longest side, or the one across from the right angle, is always going to be called the hypotenuse. That hasn't changed from just any old right triangle that we've talked about before, like with Pythagorean theorem or anything like that. The big difference is going to be the legs. So the legs of our triangle, before we haven't really had to worry too much about them, but now it's really going to be important that the one across from the angle that we're concerned with is going to be called the opposite leg, and the one next to the angle that we're concerned with is called the adjacent leg. It does make a difference as to which one it is, and if you think back to earlier in the year, the bigger this angle is, the bigger the opposite leg is going to be. So we need to be able to kind of think about the relationship between that angle and those legs. If our angle changes places, the hypotenuse doesn't change, but the other sides do. So it's still across from our angle is the opposite, and next to our angle is the adjacent. And I'll just abbreviate that because I'm definitely going to run out of room there. Now, from there, once we know our names of our sides, then we can go through and talk about the different trigonometric ratios. And all these ratios is just special names for comparing two of the sides that we have. Go ahead and write them in for you real quick here. And so if you've noticed, when we've been writing ratios, comparing in similar triangles, that kind of stuff, all of the different ratios we had showed up quite a bit. So for example, comparing the opposite side to the hypotenuse showed up quite a bit. So much so that we kind of gave that one a name, and that one is called sine. So when we compare the opposite side to the hypotenuse, that is called sine. When we compare the adjacent side to the hypotenuse, that is called cosine. And when we compare the opposite side to the adjacent side, that is called tangent. There are three other ones where we just write them in the other order. So instead of comparing opposite over hypotenuse, if we compare the other way around, we have special names for those too. But really, these three are the only ones we really need to use, because if we can use opposite over hypotenuse, we don't really need a hypotenuse over opposite. So those are the three that we've got to know. We've got to know what those things mean. They are not anything specifically deep to understand. It's just that's the definition of sine. It is the opposite divided by the hypotenuse. You just got to know what it means. So let's take a look at just doing a couple examples here, and we'll talk about kind of the steps as we go along. So the first thing I always want you to do is to identify your sides. So in this triangle, I'm concerned with this 25-degree angle. Straight across is the opposite. Down here is the adjacent. And this side is the hypotenuse. We don't actually care about the adjacent in this one, so I'll just cross it off. And from here, if I know that I'm worrying about the opposite, I don't know the opposite, and I know the hypotenuse, well, the one that's got opposite and hypotenuse in it is the sine. So I'm going to set up an equation that looks like this. So we're using sine. Our angle in this case that we're concerned about is 25 degrees. And since sine is opposite over hypotenuse, in this triangle it is x over 15. One way to kind of think about this is it's just a proportion. Sine of 25 is the opposite over the the opposite over hypotenuse of a triangle, and this is the opposite over hypotenuse in this triangle, and they are equal to each other. So I actually like to write it as a proportion, and then I will go ahead and solve it just like any other proportion. We'll cross multiply. 15 times the sine of 25. I'm just going to write that out. We're comfortable with algebra. We can write out an expression without having to type everything in our calculator. So 15 times the sine of 25. And then x times 1 is x. And we know the cross products of any proportion are equal. Now at this point, this one's kind of the easier of the two things that could happen. When we cross multiply, the x is already by itself because x times 1 is just x. So we don't actually have to do literally anything at all to solve this. It's already solved for us. We just need to go back and see what our calculator says that value is. So this would be where we want to open up Desmos. Any scientific calculator will work, but Desmos is a lot easier. And so all I'm going to have to do is type in, what was it again? I should make sure I typed the right thing. 15 times the sine of 25. So 15 times the sine of 25. Make sure you're in degree mode so that you're getting those answers correct, because all of our problems are going to be in degrees. You can see there, if I change it to radians, way wrong, because we didn't give 25 radians, we have 25 degrees. So in this case, it is 6.3 for x. And that's that. This would also be a good time to just double check to make sure that makes sense. 6.3, well, that is much shorter than the hypotenuse, so at least that makes sense. If I'd gotten an answer that was bigger than the hypotenuse, that would be a problem. So as far as those steps we did, step 1 was identify the sides. Step 2, we picked a trig ratio. Then we wrote out our proportion. We cross multiplied. And we can kind of put cross multiply and solve for x. That's our algebra step. And then step 5, only after we've already got it into x equals form, then we typed it into the calculator. Calculator. That is really important that that step number 5 comes last. I can show you an example of kind of why that is here on the next one. So let's take a look at this. Our first step here is going to be just like the last one, identify our sides. So here our 50-degree angle is up here. So that means this x is our hypotenuse. And because the 7 is right next to it, it's the adjacent. The opposite one is way over here, but we don't really care about that because we're not solving for the opposite at all. So in this case, if I have adjacent and hypotenuse, well, adjacent and hypotenuse has to be cosine. So I'm going to write my equation with cosine. Cosine of my angle 50 is equal to, this is the adjacent over the hypotenuse. So the adjacent is 7, the hypotenuse is x. Now I will write it as a proportion. So we've done so far step 1, we've identified our sides. Step 2, we picked a ratio, cosine. And step 3, we wrote a proportion. Now we're going to do our algebra step. This is our cross multiplying and dividing. So here, cosine of 50 times x is just x times the cosine of 50. And then multiplying the other way, 7 times 1 is 7. Now here you can see the difference. We do not already have it solved for x. It's not x equals, it's x times cosine of 50. So just like any other algebra equation, if you see x times something and you want to get x by itself, well, we just divide by that something. Even though this says cosine of 50, it is still something we can divide by. It's a number. It just happens to be a number that our calculator has stored in it that we're going to use to look up later. So cosine of 50 divided by cosine of 50 goes away. Now I have the equation x equals 7 divided by cosine of 50. And now I can type that into my calculator. So I'll go ahead and just type 7 divided by cosine of 50. We can see it is 10.9 when we round. And you can see that definitely makes sense. Our hypotenuse, 10.9, is longer than our adjacent side. It would be a big problem if that wasn't the case. I do want to go ahead and just show you what would happen here if we didn't wait until the end. So this is a don't do this. So if I have cosine of 50 equals 7 over x, one thing I'll see a lot of is when you do that cross multiplying, some people will go ahead and type it into Desmos right away. So if I get cosine of 50, oh, it's 0.64. So they'll write 0.64x equals 7, and then they'll divide by 0.64. And everything we're doing here is mathematically correct. The problem is that 0.64 is rounded so much but we're going to get a pretty different answer here. So if I do 7 divided by 0.64, you can see instead of getting 10.89, I got 10.93. And in that case, it would round to the same thing, but that's not always going to be the case. That could end up being off by, 0.2 or 0.3 on some problems. And that's enough to, really make a big difference in some contexts. So we would really like to not type anything in our calculator at all and just go straight to this step you're seeing here. Once you've solved, don't do this. Wait until you've actually solved it for x, then type it in. Okay, I've got one more here. I'm going to go ahead and let you, if you want, pause this video and go ahead and try that one, and then unpause and watch me do it. So I'll be back in just a second here, but you pause and do it. Okay, so hopefully you took that opportunity to try this out on your own. We'll go ahead and do this one real quick. So first thing we're going to do is identify our sides. My pen decided to stop connecting again. See if we can get it to connect. There it goes, finally. I don't know if banging it against the screen actually helps, but it feels better. So we'll identify our sides. There's the opposite, there's the adjacent, and we do not need the hypotenuse. So I'll just go ahead and cross it out there. So in this case, opposite and adjacent means we're using the tangent. Our angle is 75 degrees, and tangent means opposite divided by adjacent. So I'll write 5 over x. Then I will write this out as a proportion and cross multiply. So I've got x times the tangent of 75. I'm not going to type anything in my calculator yet. And then 5 times 1 is 5. So those cross products are equal. To solve for x, I'm just going to divide by the tangent of 75. So that is the opposite of it being multiplied by x, which will cancel it out. Now I can go in and type this into my calculator, 5 divided by tangent of 75, to see what I get. Oops. Tangent of 75. And there we go. We get 1.3. And this would be a good time to, again, just kind of make sure that that makes sense as an answer. One thing we know is that bigger sides are across from bigger angles. So 75 degrees is across from 5. This one, if you did the math, would be 15. And so the side across from it is much shorter. And so that makes a lot of sense that that would be our answer. It seems like a reasonable thing. So that's pretty much the process of solving for x. The big things you're going to have to look for are which sides are you given, which trig ratio are you going to use, setting up your proportion with the right thing on top, right? Tangent is opposite over adjacent. If you don't put the opposite side on top, you're not going to get it right. And from there, it's algebra. Cross multiply, solve the equation, and then type it in your calculator.